Hello students, today we are going to learn about superposition of light waves, and we will also derive the expression for intensity of the resultant wave obtained due to superposition of the two waves. We will also discuss what is coherent sources of light, and then we will find the condition for obtaining maximum intensity and minimum intensity of the resultant wave due to superposition. Here you see we consider a wave like a vector, and if we assume that two vectors are applied at same particle on the same particle simultaneously, then the resultant of this the resultant displacement of that particle will be given by this vector sum of the individual displacements of the two vectors. So in the same fashion we can say that when two waves are superimposed, means they are mixed together, means they are allowed to pass through the same particle, applied on the same particle, the disturbance is transferred by the wave on the same particle simultaneously, then the resultant wave obtained due to superposition of these two waves will be given by the expression y is equal to y1 plus y2, where y1 is what? Y1 is the instantaneous displacement due to the first wave, and y2 is the instantaneous displacement due to second wave, and y will be the instantaneous displacement of the particle, that is the instantaneous displacement of the resultant wave. Now we can have more than two waves simultaneously superimposed, and the resultant will be again obtained by this using the same expression by the vector sum of the individual displacements. Well, you see, we define coherent sources. What is a coherent source? If two light sources are having light emitted of same frequency or same wavelength, both are same thing, and the phase difference between those two light waves is either zero or constant, remains constant throughout the lapse of time. These are the two conditions. Now the amplitude of the light waves obtained from different sources to coherent sources may be same, may be different. That is not important. So two things are important: they should have same frequency or wavelength, and the phase difference should be zero or constant, and that pair of light source is known as coherent source of light. Whenever we have some interference phenomena, we will discuss it in the very next topic. We essentially take two coherent sources of light. Now we are intending to find the expression for resultant wave obtained due to superposition of two waves. Say y1 is expressed by a sin omega t, and y2, the another wave being superimposed, is expressed by b sin omega t plus phi, where a is the amplitude of the first wave and b is the amplitude of the second wave, and phi is the phase difference between the first wave and second wave. When these two waves are superimposed, the resultant of these two waves due to superposition will be given by the relation y is equal to y1 plus y2, and therefore we can write y is equal to a sin omega t plus b sin omega t plus phi. When you expand this term sin omega t plus phi using the relation sin a plus b equal to sin a into cos b plus cos a into sin b, if you use that relation and expand it, you get a sin omega t is already there, and you expand it, b sin omega t plus phi becomes b sin omega t cos phi plus b cos omega t into sin phi. So here you see you have an expression b cos phi into sin omega t. We take b cos phi as r cos theta. Sorry. You see we have sin omega t over here and you have sin omega t over here. So we take sin omega t common and we get within the bracket a plus b cos phi. And so we define a plus b cos phi, here you got it, a plus b cos phi as r cos theta. So that means we are taking this as some constant r cos theta. How we are in a position to do this? Because phi is a constant phase difference, b and a are also constant amplitudes of the two waves. So we can write some constant in terms of another constant. And again we are finally we have taken care of these two terms. So finally we are left with b sin phi into cos omega t. So we take b sin phi as r sin theta. We have taken it like this because again here b is constant, phi is constant, so we can take one constant and express it in another constant, in terms of another constant. Now if you get y is equal to r cos theta into sin omega t plus r sin theta into cos omega t, here now you get this expression again in the format expansion of sin a plus b. So you can write it in the terms of sin a plus b. So you get r, take r common, and then you get sin omega t into cos theta plus cos omega t into sin theta. That becomes r sin omega t plus theta. So this is the expression for resultant wave obtained due to superposition of two coherent waves. Here the value of r is what? R is the amplitude of the resultant wave, and that the value of r can be obtained using these two relations. If you square both these sides and add them together, what you are getting on LHS is r square cos square theta plus r square sin square theta. So cos square theta plus sin square theta becomes 1. So we are left with r square on the left hand side. And on the right hand side you are squaring and adding both sides. So you square it, it becomes a plus b cos theta whole square plus b sin theta square. If you expand it, you get a square plus b square cos square phi, a square plus b square cos square phi plus 2ab cos phi. And here you square, you get b square sin square phi. So when you add these terms, sin square phi plus cos square phi, you get 1, and we are left with b square. So it becomes, finally you do it extensively yourself, you will get this expression a square plus b square plus 2b cos phi. This will be the value of amplitude of the resultant wave. And what is theta? Theta is the phase difference between the resultant wave y and the superimposing wave y1. Theta is the phase difference between wave y1 and the resultant y, and that is given by the relation tan phi is equal to b sin phi whole divided by a plus b cos phi. I request you to refer to the topic which we have read in class 11. We derived the expression for resultant of two vectors added together, law of parallelogram of forces, and there you will see this expression and you will have better insight and understanding of this topic. So this is all about the expression for resultant wave. Now we are interested to find the intensity of the resultant wave. You see, we know that intensity of resultant wave is intensity is always proportional to the square of the amplitude of the wave, and the amplitude of this resultant wave is r. So r is nothing but r square is a square b square 2ab cos phi, and so intensity is proportional to amplitude square, that is r square. That means it is proportional to a square plus b square plus 2ab cos phi. This is the expression. The intensity of resultant will be proportional to the square of the amplitude, and therefore the condition for maximum intensity and minimum intensity can be obtained. How we are going to do is, let us see. In this expression, you see intensity will be maximum only when cos phi is maximum, because a, b are constant over here. So only thing that can change is cos phi. So when cos phi is maximum, the intensity will be maximum, and when cos phi is minimum, the intensity will be minimum. What is the maximum value of cos phi possible? It is 1. And what is the minimum value of cos phi? It is -1. So I will be maximum, intensity will be maximum when cos phi is maximum, that is 1. This implies that phase phi should be 0 or pi or 2 pi, etc. That means equal to 2 n pi, where n is what? N is an integer. Integer means 0, 1, 2, 3. And corresponding to this phase difference between y1 and y2, corresponding to this phase difference, we have path difference is equal to 0, lambda, 2 pi, 3 pi. How we are getting this? You see, pi phase 2 pi phase difference corresponds to one wavelength. That means the path difference should be 0 or lambda or 2 pi or 3 pi lambda, etc. 3 lambda, etc. And intensity will be minimum when the value of cos phi is minimum, that is -1. And for that, corresponding phase difference would be pi, 3 pi, 5 pi, etc. Means odd multiple of pi, and that can be represented in terms of some odd number. So we have 2n plus 1 represents a odd number, because n is an integer. We have n is equal to 0, 1, 2, 3, and corresponding to this, the path difference will be lambda by 2, 3 lambda by 2, etc. That means 2n plus 1 divided by 2 into lambda will be the path difference for having minimum intensity. This is the condition for minima, and this one is the condition for maxima. Now if we consider a case that if A is equal to B, then the maximum intensity, the maxima in the intensity of the maxima will be 4A square. Means it will be 4 times the intensity of individual wave superimposing, and the intensity of minimum will be 0. If we consider another case too, if A is greater than B, means they are not equal, then in that case the maximum intensity will have intensity less than 4 times the intensity of the higher wave having higher intensity, that is first wave, and it will not be equal to 0 in true sense. So this conclusion you yourself find it out by using this relation, the same relation. You have to use this relation and find it out yourself. I believe that you have understood it very nicely, because in most of the cases The numericals asked will be solved only when you have understood these things very nicely. That's all for today. Thank you and have a nice day.